Alright, let's say we are going to build a database and we're trying to figure out what we're going to build the database around. Well, the first thing we want to do is identify big ideas that are going to be stored in the database. So let's say we're making a database to store classes. What are involved in classes? Well, we have students, teachers, and information. Well, our first impulse may be just to go through and make tables for each of these things. All right, let's start with that. Students are going to have a name, a GPA, a major. Teachers are going to have a name, a department, and a start date. Now, we'll need primary keys for both of these, and most of the time a primary key for students, it's probably going to be student ID. For teachers, it'll be employee ID. For information, this table is made to store information about the class. So for instance, what semester it's offered, what the course title is, what the course code is. So let's start putting some of those in. Our first instinct would probably be just to link these things. So we want to link both teachers and students up to the information of the classes. So information, okay, it might make sense to have the employee ID of the teacher teaching, but if we want students to be in this course, we can't just say student ID here, because that means that each course only has one instructor and each course only has one student. Now, most courses do only have one instructor. It's very uncommon for them to have multiple instructors, though that is possible. We are going to simplify our database to allow for it to only one teacher can be assigned to each course. But for students, we're going to need to be flexible. We're going to need to be able to accept anywhere from one student taking a course as an independent study through 25 students or more taking the course. So we can't have student ID here. Instead, we're going to need another table. And let's go ahead and we're going to call this table course information. Our other table that we're going to have to create will have to have every student enrolled in a course in a single record. So let's say student A enrolls in 5 courses, they'll have 5 records in this table. Say a course enrolls 20 students, that course will have 20 records in this table. So it's going to link student ID course code, and we're actually going to pull semester out of courses and put it in here. A good name for this table would be enrollment. Alright, so now the course's primary key is the course code. We can probably put the department that the course is in here. And then the employee ID will refer back to the teacher. So let's go ahead and draw in the lines that will connect various tables. And if we wanted to, we could do enroll ID as our primary key. Let's put the multiplicity on this. So every student is, or every course, sorry, will have at minimum one student and at maximum any number of students. Every student will be enrolled in one and only one course at a time. So every record will only have a single enrollment. Courses will be one-to-one, but here, if the course shows up, they'll be one-to-many. And teachers, it only allows one, so it'll be one-to-one here. I actually made a mistake. This is one-to-many. Teachers can be attached to many different courses. But every course only has one and only one teacher. Multiplicity is tricky, but if you ever have anything that is one-to-many on both sides, for instance, students is one-to-many, and if we did students directly to courses, that would be one-to-many on both sides. A course can have one to any number of students. A student can take one to any number of courses. That is a usual indication that we need to have an intermediary table that will limit it to one-to-one. So every single line of the enrollment table only refers to one course. Every single line only refers to one student. We could have multiple lines that will allow us to have multiple students enroll in multiple courses, but we can't do that unless we were to make the enrollment table. So we need to go, if we have a line that is one-to-many to one-to-many, we need to break it up by introducing another table that goes one-to-many, one-to-one, one-to-many, one-to-one. All right, and that is how you create UML for Scratch. Go ahead and you'll be creating UML for your final database in this week's project.